Alright, so, hello. How is life? I trust it is well, and I hope you're enjoying linear equations so far. Um, they get more and more important as time goes on, so hope you're struggling well with them, and they're slowly starting to make sense, or maybe quickly. Um, alright, so the exercise we want to do right now is if we're given the equation for a line, and we're given uh, a point on another line, what is an equation of a line that's parallel to the first line and includes that point? All right, so let's kind of back up here. Parallel lines. Okay, say like we've got um, our coordinate plane here. I'll just show the first quadrant. Okay, I've got two lines. Okay, I'll put arrows on these things. They're lines. Lines. Okay, I've got two lines that are parallel, which means that they never cross. And I don't know. They look slightly. I don't know. Just yeah, that's pretty good. Okay, so they're parallel means which means you know they go off into infinity in this direction and this direction, but they never cross. Um, their paths never cross, so they're parallel. Okay, so what do you notice about the slope or the steepness of these lines? Well, they have the same steepness. They have the same slope. So parallel lines will have the same slope. Okay? But they won't occupy the same points. In fact, they'll never occupy the same point um, at the same time because they don't cross. Right? So they have the same slope, but they contain different points. Right? So that's the basic idea here. So, um, you know, I'll give you an equation for one line, and then from that, you would write the equation of another line that includes the point given. All right, so that's what's going on here. Um, so the first thing that needs to happen is it's important to um, identify the slope of the line um, to which your line should be parallel. So ID slope. Okay, because your equation is going to have the same slope. All right, that's the first thing that needs to happen. So here I've got an equation in slope-intercept form, like y equals mx plus b, and this m stands for slope. So I can see immediately, because of the form the equation is in, that the slope is -2. Now here I've got something in the point-slope form, which also tells me exactly what the slope is just by looking at it. Here I've got an equation that's in the standard form. I can't just look at this and immediately tell what the slope is, but I could turn it into one of these forms. Yeah, I mean, I'd probably convert that into slope-intercept form, and then it would be obvious what the slope is. So if it's not already in a form which just tells you what the slope is, rearrange it into a form that'll tell you what the slope is of the line to which you're trying to be parallel. Okay, so step one, ID the slope. So the slope of my line is going to be uh, -2, just like this line. But my line needs to include this point, 9, 2. So here's what we're going to do. We're going to write the equation as we know it so far. Um, y equals negative. And I'm just going to write it in slope-intercept form, just like this. I'll probably do that for... Actually, no, I'll just do it for this one. Because I'll show you what to do with this. Y equals -2x plus, and I don't know what the y-intercept is. It's not going to be 10, because then it would be the same line as this one. It's going to be some other line, so I'm just going to call that b for now. Okay. Now, I've got some critical information here. I've got an x-coordinate and a y coordinate of a point that's supposed to be on this line. So I can actually plug in x, this x for this y for this y, and then all I've got left to solve is that b, right? So if this point, in other words, if this point is on my new line here, then if I plug in x and y into this equation, it has to be true. So I'm going to plug in this x and y. So the y here is 2. So step 2, set up equation as best you can. Plug in, I'm going to say plug in info to figure out, anything else that you need to figure out to write the whole equation. So in this case, we're plugging in this point that we know so that we can figure out what b is. Then I'll be able to write the whole equation. So 2 equals -2. Now my x I'm plugging in is 9 plus b. So now I can just solve for b. -2 times 9 is -18. 2 equals -18 plus b. So to get b by itself, I would just add 18 to both sides. So 18 plus 2 is 20, so b equals 20. So now I've got all the information I need to write the slope-intercept form of a line that's parallel to this one and includes this point. So so y equals the slope, -2, times x, plus b. And for the new line, it's going to be 20. Right. So this line is not, I didn't graph. This is just an example. This is not, this is a negative slope, so it'd be going down like that. So my new line is y equals -2x plus 20. So it's actually shifted up 10 from the other line. Yeah, so that y-intercept, so it's basically what happened here is it was like this. I've got a line here where it's crossing through the y-axis at 10. Well, the line that's parallel to that but goes to the point 9,2 is shifted up from that, so it has a different y-intercept. So that's kind of what's going on here. Make that a different color. Whatever, something like that. All right. So, pardon me while I grab a gulp of coffee. So okay, so that's if you're given the equation in slope-intercept form, you can do something like that, where you grab the slope because you're gonna have the same slope, and then you plug in x and y into your equation. Y equals -2x plus b. So you plug in x and y, all you need to solve for is b. Then you've got all the information you need to write a slope-intercept form equation for a line that passes through this point and is parallel to this line. Now, if you're given something in point slope form, again, it's easy just to extract the slope there. So I know my slope is going to be 4 based on just the form. And the point slope form is y minus a y coordinate on the line equals the slope times x minus an x coordinate on the line. So I know that this means the slope. Now, these things, like I just said, it's the x and y coordinate of a point on this line. I want a line that goes to this point, not this point. So it's actually pretty easy to write an equation in the point slope form that's parallel. So what it'll go like is y minus the y-intercept, or the y coordinate of a point on the line. So I'm in this case 11, y minus 11 equals the slope times x minus an x coordinate, the x coordinate of a point that's on the line. So in this case it's 7. Boom, done. So the point slope forms are probably the easiest to deal with if you're trying to write an equation for a parallel line. And by the way, why would you do that? Maybe you're doing some scientific experiments and you see that there's a linear relationship between two quantities, some kind of rate of change going on, and then you're studying something else that you know is related that has the same rate of change but is it's a different set of values. So you want it's going to be something that's parallel, but it's going to be a different line. So I don't know, that's kind of abstract. Um, yeah, all right. So that's using the point slope form. Now, if I'm given an equation in standard form, probably what I would do is I would rearrange it into the slope intercept form first. There could be a better way. In fact, I'm sure there is. But so what do we have here? So we would have. I'm just gonna start rearranging this. 2y equals negative 3x plus 12. I just move this 3x over to the side so it's looking more like that. Now I want y by itself, so I'll just divide both sides by 2. So y equals negative 3 halves x plus, and then 12 divided by 2 is 6. So my slope is negative 3 halves. And so, now that I know that, um, I could actually what I'll do is, I mean, you could write it. You could do what I did up here. You just write y equals mx plus b, and I know the slope, so negative 3 halves x plus b. Plug in your x and y of the point and solve for what b is, and then substitute that in for your equation. Then you've written it in slope-intercept form. Um, uh, Even easier is to just, if once you know the slope and you know a point on the line, uh, it's easy to write the point-slope form. So I would just write it as y minus the y-coordinate of a point on the line equals the slope times x minus an x-coordinate, or the x-coordinate of the point on the line. So either way, point slope form is nice. Slope intercept is nice as well, whatever your preference is. Yeah.